Okay, section 8.3 is on the inverse of a square matrix. Inverses can be used to solve a matrix equations, decode codes and things like that. So they do have uses, but for now we're just learning them to learn them. Okay, the definition of an inverse matrix. A inverse is the inverse of A if and only if A times A inverse equals the identity matrix and A inverse times A also equals the identity matrix, which is very similar to when we were testing whether a function was and its inverse were in fact functions and we made it equal to X. Okay, to remind you, the identity matrix is the one that's on the left side of the augmented matrix when it's in reduced row echelon form. So for example, it might look like this, but it could also be 3 by 3, 4 by 4, 5 by 5, and as long as it has the zeros all around and then that one along the diagonal that starts on the top right. Okay, if A has an inverse, A is invertible. Okay, if it doesn't have an inverse, the method we use to find the inverse will fail, and that's how we would check. Okay, so for example, one, it says show B is an inverse of A. So to show it's an inverse of A, I'm going to multiply B times A and A times B and make sure both of them result in the identity matrix. Okay, so B times A. Again, recall matrix multiplication, row by column. So no, I don't want to write on this, but the first row times the first column. And should give me that one step. -1 plus 2. If I do row 2, column 1, I get -1 plus 1. Let's see, row 1, column 2. 2 minus 2, row 2, column 2. 2 minus 1. This simplifies to the identity matrix, which is a good sign. So it does work in one direction. It needs to work in both directions. So now I'm going to do A times B. And make sure that this also produces the identity matrix. So row 1, column 1. -1 plus 2. Row 2, column 1. -1 plus 1. Row 1, column 2. Row 2, column 2. +2 minus 1. 1, 0, 0, 1. So A and B are inverses of each other because BA equals the identity matrix and AB also equals the identity matrix. Okay, we're going to find the identity matrix because it's sometimes useful. After we find it, we can always use example 1 to prove that we didn't find the answer. Okay, so to find the inverse, I'm going to manipulate this equation. So if it is an inverse, A times this should equal the identity. If I want to cancel out the A inverse times A times X equals A inverse times the identity. A inverse times A cancel out because they give you the identity matrix. A inverse times the identity leaves you with A inverse because it's the identity element, so it actually keeps things the same. Okay, we're going to do this using augmented matrices. So if I look at the original equation, it's A times X equals I. So I'm going to set that up as, I'm going to put matrix A on the left side. Since I'm trying to find what X is and it equals, where the equals is I put the augment, I'm going to put the identity matrix on the right. Okay, I want to rearrange this equation so that it turns into X equals the identity matrix. So I'm going to rearrange this. Now I want it to be identity on the left. This will give me the inverse on the right. Okay, so the idea is we're going to start with this and we're going to convert it to this, and then this is going to produce the inverse matrix on the right. And sorry, that was a terrible explanation. Okay, so it says use augmented matrices to find the inverse of A. Okay, so to start off, I'm going to set this up by augmenting matrix A with the identity matrix that's appropriate for this size. And it said use augmented matrices because later we will use another method to find the inverse. Okay, so this is matrix A. I'm going to augment it with the identity matrix that's also 2 by 2. Okay, and then my goal is to convert it so the identity matrix is now on the left and the inverse is on the right. Okay, so I'm only going to look at this side over here, and I'm basically trying to convert this to reduced row echelon form. So I'm going to start and try to get a 0 here. Again, the method's up to you. The inverse is unique, but the method to get there is not. Okay, so I'm going to keep the first row the same. Let's see, I want to cancel out the element in 2, 1. I think I'm going to do row 1 minus row 2. Negative 1 plus 1 is 0. 2 minus 1 is 1. 1 minus 0 is 1. 0 minus 1 is negative 1. Okay, I have the 0 here. Now I'm going to get the 0 up here because I'm trying to turn this into the identity matrix, or basically reduced row echelon form. Okay, so I'm going to leave the second row alone this time because it already has the 0 I want. Okay, now if I want to cancel this one out, I think I will multiply this one by negative 2. And then combine them. So 0 minus 1, negative 2 plus 2, negative 2 plus 1, 2 plus 0. Okay, this is very close to the identity matrix on the left. I just want this negative 1 to turn to a positive 1. So I'm going to go ahead and keep the second row the same. Make sure you're extending all the way across. And then I just want to change the sign on row 1. So now this is positive 1, 0, positive 1, negative 2. Okay, I've done all my augmenting, and if I did it correctly, now because this is the identity matrix, this must be the inverse matrix over here. So make sure you write the actual answer. So the inverse of A is 1, negative 2, 1, negative 1. And because I was using the same problem as above, this is consistent with the answer we checked from before. Okay, I'm going to do one more example. This time we're going to use a 3 by 3 matrix, but we are still using augmented matrices to find the inverse. So I'm going to augment my matrix C with the appropriate identity matrix. Make sure you copy it correctly. Okay, so identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, and remember, this is C, this is the inverse. When I finish, I want it to be the inverse on the left and then the identity on the left and the inverse on the right. Okay, so I'm going to try to convert this to row echelon form, reduced row echelon form. I'm going to start with zeros right here. There's actually already a 0 here, so I just need the 0 here. So I'm going to keep the first 2 rows exactly the same. But I do need to create a 0 here. So it looks like maybe row 1 minus row 3. Okay, 1 minus 1 is 0. Negative 2 plus 2 is 0. Negative 1 minus 0. 1 minus 0 is 1. 0 minus 0, 0 minus 1. Okay, let me keep going. Okay, I have those zeros here, which is good. I would normally try to get a 0 here, but it kind of actually just appeared for me. So I'm going to go back up to this column and try to create zeros along here. So if I want to get a 0 here, I'm going to cancel it using row 3. So maybe row 1 minus row 3. And the method is, again, not unique, but the resulting inverse will be. So 1 minus 0 is 0. Negative 2 minus 0. Negative 1 plus 1 is 0. 1 minus 1 is 0. 0 minus 0. 0 plus 1. Okay, now the second row, I also want to get a 0 here. I'm going to use row 3. Let's see, 2 times row 3, and then I can add it to row 2. Okay, 0 plus 0, 0 minus 1, negative 2 plus 2, 2 plus 0, 0 plus 1, negative 2 plus 0. Did I make a mistake? Yeah, I did, huh? I forgot to add the 1. 0 plus 1, negative 2 plus 0. Okay, I think that's better. And then the third row, I didn't actually change because it already had all the zeros I need on it. Okay, let's see. I have zeros here, so my last move is to get a 0 here, which looks like maybe if I multiply the second row by negative 2, that might be a good way to do it. Second row by negative 2, and then cancel it with row 1. Okay, so that's 1. 2 minus 2 is 0. 0 minus 0. Negative 4 plus 0. Negative 2 plus 0. 4 plus 1. Okay, now I kept the second row the same. And the third row the same, although really I could have probably canceled the negative on the same step if I wanted to be super efficient, but I'm okay with not being super efficient. Okay, I'm almost to where I want to be. So the first row, the left side does look like the identity matrix, so I'm going to leave that one alone. Okay, for the second row, I just need to cancel that negative on the 1. So I'll divide by negative 1 times by negative 1. Change the signs. Okay, in the third row, same, I need to change the sign. Okay, so if I did this correctly, now that the identity is on the left side, the inverse should be on the right side, except that's not A, that's C inverse. Okay, so C inverse should equal to negative 4, negative 2, 5, negative 2, negative 1, 2, negative 1, 0, and 1. If I wanted to check my answer, I could multiply C times C inverse and C inverse times C to confirm that I do in fact get the identity matrix as the result both directions.